everybody. Welcome to my channel. I'm Ashley Morris, the owner and lead tutor at amtutors.com. And we're starting a series today where we're going to talk about systems of equations and we're solving them by graphing to start out. When we are solving by graphing, we do need graph paper, so go grab some graph paper before we get started. A system of equations is two or more equations that have the same variables. So here we're using x and y. To solve this, you need the same number of equations as you have variables. So I've got two variables, x and y, and I've got two equations. We are going to solve these by graphing. And where they cross is the solution. We want to know, where are these two equations the same? So we're going to graph one, we're going to graph the other, and we're going to see where they cross. That is when they are the same at the same time. All right, so let's graph this first one. The slope is 2. I'm going to put 2 over 1, so I know my rise and my run. And my y-intercept is 1. I'm going to do this one in blue. So here's my origin. I'm going to go up 1 and put a dot. And then my rise over run tells me I go up 2 and over 1. I don't have any space to go up again. So if I come back here and I go down 2 and left 1, that also works. Down 2 and left 1. And then we connect our dots as best we can. Use a straight edge if you've got one. So that's my first line. Let me switch colors and do my second one. For this one, the slope is -1 over 1. You can also do 1 over -1. One of them has to be negative. It doesn't matter which one. And my y-intercept is 4. So here's my origin. We're going to go up 1, 2, 3, 4. And then for this, we're going to have to go down and to the right. I can't go up and left. It's somewhere over here, but I don't have graph paper for that. So I'm going to go down and right. Oh, I already see where they're the same. Down and right. We try and do several ordered pairs because we want to make sure we want to do several dots. That way, if we make a mistake somewhere, we can see like, oh, wait, that doesn't connect. All right, so we've got four ordered pairs graphed. So those are my two lines. Now, if you're having a hard time graphing these, please go back and watch our videos on just graphing. So I've graphed both of these. The solution is where they are the exact same. That's this point right here. So let's count. Here's our origin. We went over 1 and up 1, 2, 3. So my ordered pair, 1, 3, is my solution. Now we are able to check this by plugging in x and y into the first equation and the second equation. I am going to do it for one. I'll do it for this one problem. I'm not going to do it for the next one. So 3 equals, I'm going to put a question mark because I hope it equals 2 times 1 plus 1. 2 times 1 is 2, plus 1 is 3. So yes, check. It worked for the first one. Now let's check it for the second one. Does 3 equal, run out of space, -1 plus 4? Yeah, that's 3. That equals 3, so check. It worked for both of them. It better make both of them true. This is the way you can check your work at the end. I am going to do another one, so don't go away. Okay, here's another system of equations. We've got x and y. We're going to graph it just like we did the last one. And the nice thing about this one is that they're both y equals. In this video, we're only doing y equals already. That may change in the next video. So for this one, my slope is -2 over 1, or I could write that as 2 over -1. Depends on what fits over here. And my y-intercept is 5. So here's my origin. 1, 2, 3, 4. Ooh, 5 is up here. Okay, this is why graphing is not always the best. I don't know for sure that that's 5. I know it's close though, so we're going to make it work. But this is an excellent example of why graphing is not always perfect. If my graph paper isn't big enough, if my ordered pairs somehow are decimals, that's why graphing isn't always the best. But we're going to do our best on this one. All right, so we're going to go down 2 and over 1 to the right, down 2 positive 1, down 2 positive 1, down 2 positive 1. All right, I'm getting my graph as good as I can get it based on what I know. Now let's do this other one. M is 1 over 1, or you could say -1 over -1, depending on where our graph is. And then our y-intercept is -4. So I think I can get this one. 1, 2, 3, 4. It's way down here. Way down there. And then we're going to go up and right. You can also go down and left, but I don't have any graph paper for that. Up and right. +1, +1. Oh, look at that. I was able to make it work. So once you got your dots, connect your dots. So there's my first line. Here's my other line. Now, where did they intersect? Here's my origin. 1, 2, 3, 3, -1. And you can go back and plug them in. We got lucky. That was at a perfect crosshair. We got a little unlucky right here because my graph paper wasn't big enough. But when these work out, they're beautiful, right? But it only works really well if the ordered pairs are pretty integers, like this 3, -1, and our graph paper is big enough. We will learn what to do if that doesn't work in other videos. Right now we're graphing, and I'm going to make sure that they're as nice as I can get them. I hope this was helpful. Please make sure you go back and watch more on graphing just lines if this was tricky. Also, reach out to us at amtutors.com. We'd love to set up some tutoring sessions with you with our certified math teachers. Also, like and subscribe so you always get the latest and greatest math content when we post it. Have a great day.